Hello, everybody. All right, so we are going into quadratic functions. Now, this is a topic that everybody in here has seen before. You've had a couple of years experience at it, so hopefully this will be a nice, easy section for you, and it'll be just mainly review. So we're going to look at parabolas, we're going to graph some parabolas, we're going to determine min and max points, and then we're going to solve some random problems. So let's jump right into this. So we're going to look at quadratic functions. We're going to start off with vertex form. But before we get into that, let's refresh your memory. This is your quadratic equation plotted out. When you plot it out, you get a parabola. Okay? So when we're looking at this, you will notice that we have a couple of different, yet they're the same types of characteristics. Regardless if it opens upward or if it opens downward, we have a vertex. The difference is if we have a parabola that opens up, we have a minimum point as our vertex, or if it opens down, we have a max point as our vertex. Also notice at the vertex, you have your line of symmetry. This is the line that cuts the parabola in half. So the line of symmetry and the vertex are going to be the same on both, with the exception of if it opens up, your vertex is a minimum, and if it opens down, your vertex is a max. So that vertex is that turn point in the parabola that will determine what the other half of the parabola is going to look like. So I just talked about that the vertex is a turning point. It's either going to be a minimum or a maximum point. It's also where the line of symmetry is located. So whatever your line of symmetry is whatever that x value is on that vertex. So when you're trying to figure out what your line of symmetry is, or you also might hear it as axis of symmetry, they're both the same thing. Whatever your x value is, that would be the equation. So x equals whatever that x point or x value is in the actual point. So then we have what's called standard form, or what's also called vertex form. So this is what your standard form of a quadratic function looks like. When you're looking at this, notice that your vertex is your h and k. So just like back in circles, your h and k represented the center. For a quadratic, your h and k represents the vertex. Your line of symmetry is the x equals h, so whatever the h portion is. Also, your a value here, if it's greater than 0, your parabola is going to open up, so it's going to do that. And if it's less than 0, it opens down, which means it's going to do that. Okay. So you'll see standard form. Your standard form is also called vertex form. So they're the same things. The difference is just the textbook, to be completely honest with you, but they both mean the same things because when you're in this form, this and this will actually give you your vertex itself. Okay. So when you graph these, so the easiest way to do it is when you have a formula that's given to you in this form, you first need to determine, do you open up or do you open down? That's the first thing you're going to decide. So you're going to look here at the a value. The next thing you're going to do is you're going to determine the vertex, which is going to be your h and k. And then the last thing you're going to do is you're going to find any x-intercepts by solving for that. Okay. So those are the main three things that you're going to do when you go through this process and you try to figure out, how am I going to graph this? What different pieces of information that you need? You're going to go through these three things. Now, there's other additional things that you'll need to look at as well, though. Once you figure out your x-intercept, your y-intercept is literally going to be, you're going to plug in a 0 for this and then just figure everything out from there. Because when you plug that 0 into here, that'll give you, when x is 0, your y is going to be whatever's left over. And then you're going to plot all your points. So you're going to plot your x and y intercepts. You're going to plot your vertex and any additional points necessary. Now, when you're doing this, the key for number 5 is you should have at least 5 points. So you need your vertex. That should be one of the points because that's going to be dead center. You need your y-intercept. You need your x-intercept. Now, and you can have one x-intercept or you can have two x-intercepts. So it's going to depend on the equation itself. And then you get to pick the other points. So when you graph these, don't forget you have your line of symmetry. So you have your vertex here. Well, if you've got a point right here, because it's the line of symmetry, however far away that is, if you go straight across, there's your other point. So if you have a point that sits right here and you go straight across, there's the other point. So you can graph all your points and you should have about 5. Now, your homework might tell you a different number or whatever. It might just say just plot your intercepts or just plot the vertex and a couple of other points. So pay attention to your directions on that. However, typically you should have 5 points when you actually graph a quadratic, which is what I just said right here. So let's take a look at this. We want to graph this function. So the first thing we're going to do is, does this open up or does this open down? So we're going to look right here at the a value. Well, the a value is negative, so this is going to open downward. Secondly, I'm going to look at my vertex. So my vertex comes from this number here and this number here, which means that my vertex is going to be a 1, 4, because remember your h is whatever number's here. So if this is negative, your h is positive. If this is positive, your h is negative, so don't forget that. Then we're going to find, let's go with our y-intercept first. So what we're going to do is we're going to come over here and we're going to say f of 0 is equal to negative 0 minus 1 squared plus 4. So that gives me negative 1 squared plus 4. So that gives me a negative 1 plus 4. So that gives me a 3. So my y-intercept is at 0, 3. And then we're going to find our x-intercepts. And our x-intercepts are when my f of x is equal to 0. So I'm going to say 0 is equal to negative x minus 1 squared plus 4. So I'm going to go ahead and move my 4 over. So that gives me a negative 4 is equal to negative x plus 1 squared. I'm going to divide both sides by that negative. That gives me x plus 1 squared. I'm going to get rid of my square by square rooting both sides. Remember, when you square root, you get a plus and a minus. So I've got x plus 1 is equal to 2, and x plus 1 is equal to negative 2. So when I solve this, I get x is equal to 1, and x is equal to negative 3. So my x-intercept is at negative 3, 0, comma, 1, 0. So I have 4 points here I'm going to plot, and I know this opens downwards. So I'm going to do that, and I know it opens downwards, so I'm just going to pick an additional point. It doesn't matter. Well, since these are already directly across from each other, I'm going to go, this one's 1 away, so I'm going to go that one. And then there you go. When you plot it, you get your parabola that looks something like that. Okay? So vertex, y-intercept, 2 x-intercepts, and then my extra point that I used. All right, your turn. Take a moment, pause the video, and answer these questions and see if you can plot this function. And pause it now. All right, welcome back. So let's see how you did. So we know that this is going to open upward. I did not. And so since that one opens upward, we have a vertex that's going to be at -3, 1. We have a y-intercept that's going to be at 0, 10. And we have our x-intercept that's going to wind up being, let's see here, 0 is equal to x plus 3 squared plus 1. -1 is equal to x plus 3 squared. So that gives me the square root of -1 is equal to x plus 3. Remember, that's plus minus. And the square root of -1 is just I. So I've got I is equal to x plus 3, and -I is equal to x plus 3. So I wind up with -3 plus I is equal to x, and -3 minus I is equal to x. And so these would be my x-intercepts. And so when I plot it, and if you notice it doesn't touch, which is exactly what it's supposed to be. And again, if I plot my extra points, I just go straight across from what I'm looking at. And there you go. When you notice that we got these imaginary numbers here as my x-intercepts, that means this graph is not going to touch the x-axis at all. And if you remember when we did the discriminant, it told you that if you ran the discriminant first, then you'd be able to determine if you're actually going to have any solutions. And this one actually does not have any solutions. Okay. All right. So let's look at standard form. Okay. So standard form looks like this. The ax squared plus bx plus c, which means that the parabola's vertex is going to be this piece right here. Okay. So negative b over 2a, if you take a look at that, that's part of your quadratic equation. So the negative b over 2a, that's that portion of it, this is the this is going to be your line of symmetry. So this negative b over 2a is your line of symmetry or axis of symmetry, either or. And then you take that answer and you plug it back into your equation right here, and that's going to give you your y point, which gives you your vertex altogether. So just remember, when you're looking at this, negative b over 2a winds up being both your line of symmetry and the x-coordinate of your vertex. Take that answer, plug it back in, and you wind up with your y-coordinate, which means you'll actually wind up with your whole entire vertex. And the same rules apply, okay? We have ax squared plus bx plus c. So again, if my a is bigger than 0, it opens upward. If it's less than 0, it opens downward. There's my negative b over 2a, and there's the y value that goes with it. And then you're going to factor this using all of our factoring skills that you have been taught up to this point to find your x-intercepts. And then again, you're going to plot and find your y-intercept as well, and then plot your points and connect the dots. So just to give you a quick remembrance, this is what it should look like. So if you're looking at something like this, you know you're going to go like that. If you're looking at something like this, you're going to go like that. So we want to graph this quadratic here. The first thing I want to do is go ahead and find my line of symmetry. Not my line of symmetry. I want to find out first off, does it open up or down? Well, we know that that's a negative, so we know that we're opening down. Okay. So now what we want to do is we want to find our line of symmetry piece. So that is negative b over 2a. So negative b, so negative 4 over 2 times negative 1. That gives me negative 4 over negative 2. So that's going to give me a positive 2. So my line of symmetry is going to be at x is equal to positive 2. So that means on my vertex, my x coordinate is going to be 2. So then I evaluate at that x point. And so I wind up with negative 2 squared plus 4 times 2 plus 1. That gives me negative 2 squared is 4 plus 4 times 2 is 8, and then plus 1. So that gives me 4 plus 1, so that gives me a 5. So my vertex is going to be at 2, 5. Okay. So now my y-intercept is going to be the easier one to find. So I'm just going to plug in a 0, which means that and that goes away. That leaves me with just this piece right here. So my y-intercept is going to be at 0, 1. And then I'm going to find my x-intercepts. So if you notice here, I have this lead term that's a negative. I don't really want to deal with that if I don't have to. So what I'm going to do is I'm going to switch everything. So I'm going to say x squared minus 4x minus 1. And that's going to equal to f of x. But the problem with this is I can't factor this. So I'm going to have to use the quadratic formula, which basically what that means is you're not going to have a really pretty number. So when you're graphing these, sometimes if you don't have that pretty number, sometimes it's best to skip this piece right here. And so what you need to do then is you need to rely heavily on your line of symmetry. Because if you do that, then again, as long as what you do to one side, you do to the other, that rule still kind of applies. So I know I've got my vertex up here, and I've got my y-intercept here. So if I literally go straight across from that y-intercept, then I'm going to wind up having another point right here. So if you notice here, I went ahead and plotted the x-intercepts, and notice they're just not pretty numbers. I mean, I have no idea what those numbers are, but I just know that they're not really nice. It's not a clean number like 4.5 or something like that. It's a 4 and some decimals, and this is going to be some really small decimal over here. So when you're doing this, I was able to actually look at using my x-intercept and using the line of symmetry, and then coming up and trying to find another point anywhere along here that I could possibly find to give me another one. And then you just plot your points. Now, y'all have a calculator at your disposal. Use that. Use that to find your zeros if you need to. A lot of this graphing stuff is a guesstimate work in a way. So you're going to be able to actually just kind of plug this in and kind of say, okay, that's really close to 4, so I'm looking at this one because it's a multiple choice answer. And you just kind of guesstimate it a little bit, okay? All right. So graph this function. And then what's the domain and range? So this one's a little bit different. So first off, we're going to look at opens up or opens down. Well, that's a negative, so we open downward. Negative b over 2a. So negative a negative 2 all over 2 times a negative 1. That gives me a positive 2 over negative 2, which gives me a negative 1. So I didn't write that down. Or did I? Nope. So my line of symmetry, my LOS, is going to be at x is equal to negative 1. So that's this first part right here. So then I take that negative 1, plug it back into here. So f of negative 1, that's negative 1 squared minus 2 times negative 1 plus 1. So this gives me a negative 1 plus 2 plus 1. So then I wind up with a plus 2. So my vertex is going to be there. Now, here's the interesting part about this. Once we figure out our vertex and whether if we open up or down, then we can look at our domain and range. You need to remember domain will always be negative infinity to positive infinity. Okay, that's always going to be your domain when it comes to a parabola unless you're bounded. Your range is always going to be off of your vertex. So it's either going to be negative infinity to your y value, whatever that might be, or it's going to be your y value to positive infinity. It just depends on this answer right here. Since we are opening downward, we're going to be from negative infinity up to that specific y value here. If it opens upward, you're going to start at this y point and go off to positive infinity. So when I look at my domain and range, for this specific one here, my range will go from negative infinity all the way up to a positive 2, and it will include it. And so it will need a bracket there. Okay. For those of you who keep putting this into x is less than or equal to 2 into your homework, I will no longer count it if it's asking for interval notation. It has to be an interval notation. That's an interval. This is not an interval. So if you're going to continuously put this into interval notation, I'm going to continuously mark that wrong because that is not what the question is asking. It's asking you to put it into interval notation. You need to do that. Okay? So please, interval notation looks like this. My y-intercept. My y-intercept is going to be 0, 1. And then my x-intercept. So again, I'm going to sign change everything. So I wind up with x squared plus 2x minus 1. Again, this is not going to be another pretty one. Why do I not have any pretty ones here? I'm sorry, guys. So again, quadratic equation will get you that, that number or whatever else, and you'll just stick that into here. So if you're trying to remember quadratic equation, that is going to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So it gives me negative 2 plus or minus 4 minus 4 minus 1. So that'd be 4 plus 4, which is the square root of 8, all over 2. The square root of 8 is plus or minus 2 square roots of 2, all over 2. So when I clean this piece up here, I wind up with, let me get rid of that. I wind up with negative 1 plus or minus the square root of 2. So that's where I'm going to intercept the x-axis at. And as you can see, when I plot my points and everything, that's what I wind up getting. All right. Min-max points. That is going to be solely focusing on your vertex themselves. So you just need to make sure that if my A is positive, that means my vertex is going to be a minimum point, and if my A is negative, that means my vertex is going to be a maximum point. So that's what you have to look at for that piece. Kind of already talked about that. So without graphing, I need to determine, does this have a minimum or maximum value? So I'm going to look here at my A value. My A value is positive, so I know I'm going to have a minimum value because that means I'm opening up. I'm doing something that looks like that. To find out where that occurs, so that's going to be my negative B over 2A. So I've got 16 over 2 times 4. So that's 16 over 8. That gives me a 2. I take that 2 and I plug it back into here. So I get 2 squared with the 4 minus 16 times 2 plus 1,000. So that's 16. So that's minus 16 plus 1,000. So my vertex happens, oops, not there. My vertex is going to happen at 2 and then 984. We know that's a minimum point, and since this is a minimum point, that means I'm going to start at this point, 984, and I'm going to go off into positive infinity, and this is my range. Remember, your domain is always going to be all real numbers. Okay? So, no graphing here. I'm just answering the questions straightforward. So, hopefully that's not going to be too difficult to be able to do. All right, we did that one. We did that one. Did that one. Okay. So let's look at some applications here. So when you're reading or when you're doing applications, usually in the application, they actually give you the quadratic function that you're going to be using, which is going to be nice. But make sure you read it to determine, are we finding something that's going to be minimized or maximized? What are we doing here? And if at all possible, we kind of want to rewrite it into this format here, so we'll be able to factor this a lot easier. If you need to, this may not be something you need to do, but if you need to do that, make sure you calculate your minimum and maximum values as well, okay? So you have 120 feet of fencing to enclose a rectangular region. Find the dimensions of a rectangle that maximize the enclosed area. So we have 120 feet of fencing to enclose a rectangular region. So what this means is that I need to take this this fencing thing here, and I am going to, I want to be able to